Okay, so we're going to do some investigating with an angle bisector. We haven't seen this yet in our triangle, so let's just kind of see, what does this give us? What happens? So in triangle KLM, that's the big triangle KLM, NL right here bisects angle KLM. So you can see we have two congruent angles because LN is bisecting it. We're going to compare the ratios of KN over MN and KL over ML. So what we're looking at is, well, I'll show that in a second. And then after we compare those ratios, we're being asked if the two triangles are similar, and then let's explain what we come up with. So let's go ahead and set up those ratios and see what we think. So KN over MN, that's the first one they want us to look at. So in the picture, KN is formed by, see where that angle bisector hit the opposite side, KN, and then MN is the other part of that side. So this KM got split somehow by an angle bisector. All right, well, KN is 10.5, MN is 7.5, and if we divide that out, we get 1.4. All right, now they want us to compare KL and ML. So KL and ML are those two sides. So KL is 14 and ML is 10. 14 divided by 10 is 1.4. So you can see we're getting the same ratio. Our ratios are equal to each other. Does that mean that you have congruent triangles? So I guess we should have looked at this. Where are these triangles? So LKN is this triangle, and then LMN is that triangle. So are those two triangles similar? Now we saw in our right triangles in our last lesson, a right triangle that has an altitude hitting the hypotenuse gives you similar triangles. So do we have similar triangles when you have an angle bisector? Well, we cannot say that the triangles are similar with just two congruent ratios. That would be a side-side similarity, and that's not a thing. We need to check the third side to see if we have a side-side-side similarity. Okay, so the third side that we haven't used yet, so the third side of our green triangle, we did KN, we did KL, but we haven't done LN. So we're going to do LN over, and then the third side of the other triangle, we used LN, we used NM, but we have not used LN. So what we notice is we have LN divided by LN. Well, anytime, however long LN is, which I have no idea how long it is, but I do know that I'm taking something and dividing it by itself. Anytime that happens, you get 1. So this ratio is 1. You have a 1.4 ratio, a 1.4 ratio, and a 1 ratio. Does that fit our side-side-side similarity criteria that we're trying to meet? And no, it doesn't. We do not have 3 ratios that are the same. So are the triangles congruent? Well, the ratios are different. 2 of them are the same, but we had to check the third side. Ratios are different, so the triangles are not similar. So just to recap, when you have an angle bisector, you will have some proportional sides. We had 2 sides that were proportional, but you won't get that third side to be proportional, so this does not give us similar triangles, but it does give us some of the same proportions.